Hi there, welcome to GeeklyEDU Math. In this video we take a look at the common logarithm, taking a look at where it's coming from, as well as taking a look at the relationship that exists between the common logarithm as well as the common exponential function. So, to start off with, one would have to have an understanding of how do you write something from exponential form to logarithmic form. So we've got an exponential form there of a to the power of b is equal to c. So we've got a, the base, b, the exponent, and c, which we're going to refer to as the number. So writing that in logarithmic form, we have log of the number. So the number in that case would be c, and we would have the base at the bottom is equal to the exponent. So that would be log c to base a is equal to b, the exponent. So logarithms are quite useful in assisting us to solve for an unknown, which is an exponent, of which we cannot go about it the normal way of solving it exponentially. So that's how we go from exponential form to logarithmic form. Now, in assisting us with the derivation of this logarithmic function, we are asked here to find the inverse of the following. So it's finding the inverse of that common exponential function there. So finding the inverse, we would first have to switch the positions of x and y. So here we would have x is equal to a to the exponent y. Because inverse is the reflection of a function about the line y is equal to x. So then we would have to interchange the positions of x and y. Now our objection is finding y, while we just learned now how to write that in exponential form. So we would go and say log of the number, which is x, to the base, and that would give us the exponent. Right, so then the inverse function of this common exponential function is given by log of the number x to base a. Now, taking a look at the sketch of the logarithmic function as well as the exponential function. So here we've got the sketch graph of the common logarithmic function. So given by, we're going to call it f of x in blue is equal to log of x. Now, you might note that we don't have a base here, so what's quite interesting is that if we don't have a base, well, the base would always be 10. So now sketched here, we would call the inverse function of the log function, which is the exponential. Both these functions are inverses of each other. This would give us base 10 to the power of x. And one can clearly see that these are inverses of each other. So the red, the common exponential, is reflected about the green line, which is the line y is equal to x, to form the common logarithmic function there. And we can see that the y-intercept of the exponential function has become the x-intercept. So those two values, 0 and 1, has interchanged to 1 and 0. Now, what's interesting out of the log function is that you notice that it's only defined for the positive x values there. So the range is from negative infinity to infinity. However, we only use the positive x values. And so having that in mind helps us with the following. So here we have an exercise for which asks us to find values of x of which this expression is defined. So we took a look at the graph well, the graph has told us, or we have seen from the graph, that the log graph is defined for the positive x values. So now if we are given this function here of log of 2 minus x, well, what do we have to do here? We are going to have to set the 2 minus x to be greater than 0. And therefore, solving this out, we see that x is less than 2. Another way of representing this is to put the x first, to say x is less than 2. So in other words, we only are required, or we can only use values from negative infinity right up to 2 excluded, because the log function is defined for the positive x values except 0. Alright, so that's something to look for there for the values which are defined for this specific log function. Alright, well, that's it now with the brief discussion of the common logarithm. I would strongly encourage you to please subscribe to GeeklyEDU to watch other videos of other topics which you might be interested in. Thanks for now.